Hi, this is my talk, Introduction to React. I'm Ryan Goldstein. Let's get into it. So before we begin, if you have your laptop, you can go to this link, and that's where the code for the project we'll be doing will be. We'll be looking at various parts of this and looking at the code. This lets you run it in your browser without having to download anything, because downloading the whole npm toolchain probably would be a little time-consuming. So it's repl.it, R-E-P-L.it, /@ Ryan Isaac G, RYANISAACG /React HH. So let me know if you have any problems or if you're all good. Okay, so yeah, you can actually also fork it and then edit it locally, so you can make changes to see what that would produce. It should update automatically in the pane in the top right of your browser. If you don't have a laptop with you, or if you don't want to follow along locally, I'll be doing everything up here also, so you can just follow along visually. So who am I? I'm a Rutgers junior studying CS. For the past 2 summers, I interned at a company called Vidya. They're a React and React Native shop, which is where I picked up a lot of this. I'm going to be focusing more on the web development side of React than the mobile development side, mostly because that's where my experience is. I'm the new web front-end lead for React, for HackRU, which uses React. So the website dashboard is in React, and I'm going to be working at Facebook this summer. Facebook, coincidentally, makes React. So today's talk is going to be kind of anchored around an example, which is a to-do app, and it's going to have 3 things it can do. We're going to be able to add tasks with text, going to be able to check off tasks or uncheck tasks, and automatically move checked off tasks to the bottom. So we're not exactly inventing the next great Todoist clone here. We are going to make something that has some dynamic content to it, and you can see state management and all that. This is a screenshot. If you're writing the code locally, it should look something like that. I think that's taken in Safari, and it looks a little bit different in Chrome. I do recommend you run it in Chrome, by the way, because in my experience, Safari and Firefox kind of runs really badly, but in Chrome, it was running fine. So we're going to do 3 main things, or look at 3 main things in the application: a smart component that manages the state, a dumb component that renders data, and then using atomic CSS. We'll get into what all this means shortly. So before we jump into the actual code, let's go over some fundamental concepts, what React is and how you use it. React is not made in a vacuum, so React is definitely made in reaction to the traditional way of doing web development. So that was, HTML5, CSS3, and Java, ECMAScript 5. So the web platform was really built kind of haphazardly out of what started as hyperlinked documents. So Tim Berners-Lee thought it'd be really great if we could write a document that linked to other documents. And then someone was like, wow, this document looks awful. What if I could add styling to it with CSS? And then you have CSS, which evolves over time. And someone later, Brendan Eich, was like, okay, what if our browser had a scripting feature? We'll make a language really quick and call it JavaScript. And JavaScript was intended for short scripting things. So you have a document platform, a basic styling system, and a very basic scripting language that have kind of evolved into the only platform people consume applications on, which kind of gets unwieldy. It's really hard to reuse code you've built. So if you've ever written HTML, there's no way to define a function in HTML or define a way to reuse something. You just kind of write it out every time, which kind of gets a little wordy. So if you think about programming in terms of declarative, imperative, and functional paradigms, if you've taken printprog 314, that'd be kind of familiar. Whereas imperative, you're going to give commands to the computer like C or Java. You're going to tell the computer, do this, then do that, then do this other thing, right? And that's kind of how JavaScript works most of the time. Declarative, you kind of just describe a finished product and let the computer handle it for you. So in CSS, you say, put a margin around this with 3 pixels. You don't worry about, okay, make sure this element is this far away and find all the other elements. You just kind of tell the browser engine, this is what I want, and it goes out and does it. And functional, you kind of define inputs and outputs of data flows, and you can run data through it without modifying global state. So the idea with functional programming is kind of a broad spectrum, but it's to minimize global state. Because if you're working on a small code base, let's say you have 100 lines of HTML and 100 lines of JS, right? You can read the whole thing in maybe 5 minutes. And you can kind of understand what's going on, right? Do you have 1,000 lines of HTML and 10,000 lines of JavaScript, and you have like 30 event handlers, you're going to have weird side effects popping up all over the place. And in my experience, it's really hard to debug that because, okay, why does the page kind of look wonky after you click the button? Well, there are 30 different things every time you click the button, and they're scattered all across this, many thousands of lines of JavaScript. It's much nicer to have everything contained locally. So that's what React's all about. Components are a way of containing both kind of the HTML and the JavaScript of specific page elements in the same spot. So everything in React is a component, and components are made of components, which are made of components. So if you can think of your application like a tree of components, the leaves at the bottom are HTML elements. So if you've done web development, you're familiar with things like divs or paragraph tags. Divs are basically how you group a bunch of elements together for the web. So that's the base thing you build on. React gives you all the HTML elements as components. Then you build your own component library on top of that. So if you had, for example, a to-do list item, which we'll get to soon, you might want to combine a checkbox and a paragraph tag in a div, and it brings it all together, and you don't have to write out everything every time. It's defined in JavaScript, and it's focused on code reuse and code maintainability. So components are kind of immutable, which means like you can't change them or edit them. The advantage here is that way it's more debuggable. Components can't change underneath you while you're working, so you are really aware of what causes what effects in the system. Because if you ever debugged a system that did things kind of without, seemingly without reason, it's impossible to track down bugs in that sort of scenario. So components take input as properties. You can think of properties as sort of like parameters to a function. So if you've ever done web development, for example, an input tag will take, what type am I? Am I a checkbox? Am I a radio button? Am I a text box? And it'll take, am I checked off? What's my value? That's all properties. Components are only rendered once. They're re-rendered when things change, if they need to be. So you don't have to worry about how do I edit elements to update them to be what I want the content to be. If you're using like jQuery and doing an old style kind of rich text app, you might do document.getElement.ib or by ID or the jQuery $sign selector. You have to go through and manually change all the values. React, you just say, this is what it should look like, and the React engine updates it for you. And you can use something called state, which we'll get into later, to keep track of interior things that can change, instead of just being locked to static, unchangeable content. So the React syntax, the last thing we got to do before we can get into the actual code, is JSX. It stands for JavaScript XML, which is like JavaScript, but there's XML. So HTML is descended from XML, which uses these tags in angle brackets to delimit tree structure of data. So you can use angle brackets to insert JS values into what's basically an HTML document. So I was talking about a counter before. If you have variable count equals 0, you want to insert the value of count into this div as text, you just put in brackets count, and then it gets inserted for you. If this gets updated, that will get updated automatically. You don't have to worry about going into the document and editing things. So then, if we wanted to pass some properties, like I was talking about, you'd say the prop name equals, and then the value you want to assign to it. Props, you can give them a double-quoted literal string, or you can just give them any arbitrary JavaScript expression. So let's dip our toe into the actual code. Yes?
Are you allowed to use namespaces with the XML stuff with this?
Namespaces how?
I don't know, just for specific things in there.
Yeah, you actually can do, like, for example, if you have there's a component in the React library itself called fragment. You can do, like, react.fragment to refer to that. Generally, I import everything into local scope, but that's just a stylistic choice I'm making. So dipping our toe into the application itself. If you missed it, here's the link to see the running version of the code. Does everyone have that open? So it's written up there if you need it. So let's. So as we can see here, we have our running version, our to-do list over here. We have our code here, console output, and our source tree. So this is the task file. Fits all. So 15 lines, nice and kind of succinct. How's everyone's familiarity with like JavaScript and ES6? Like good, really bad, bad? Good? Okay. I'm going to assume at least some people here need the general, more arcane kind of syntax stuff explained, because this kind of gets into some JavaScript-specific stuff. So the first line, import React from React. It imports React. You have to do that anytime you use JavaScript XML because of the way it's compiled. So just import React and move on. Const task equals. So basically, we're declaring a constant variable task and setting it equal to this, which is what's called a fat arrow function in JavaScript. So there's two things happening here. There's a fat arrow function and there's destructuring. So let's demonstrate both of those outside the context of React. In a much more simple example, we can see this is an object. It's got two keys, A and B. A is 10, B is some value. Then on line 5, I did what's called destructuring or pattern matching, where basically you write out kind of like, okay, object has a key A and a key B, and I want to make a variable A, which is object.A, and a variable B, which is object.B. So we can see here, A and B match the values we put into object. So that's just a convenient way to, it's like a bit of syntactic sugar to easily write a way to get things out of objects without having to write the object name over and over again. So an alternative to that over here, we have this right here, destructures the parameter to the function. We could just write props and then write props.completed, props.onChange, and props.text. We could just do that. Props is the shorthand for properties in React code, but it's just kind of a little bit more wordy. It's just nicer to do it like this, and also you get the built-in little documentation of what properties does it expect. It expects completed, onChange, and text. So fat arrow functions in JavaScript also have a little difference from normal functions, which is that if you only have one thing, you're just calculating one value, you can just write that expression. You don't have to write a return statement. So we defined add here. So add takes parameter x, parameter y, and adds them. So add 2, 3, it's 5, yeah. So I put that together, you add object. Destructures object, takes key A and key B and adds them. So if we add 10 and some value, we get 10 some value, right? So if we go back over here, task is a function that takes an object, breaks that object up, and turns it into a div, which is kind of like a box in CSS that wraps around its contents. A checkbox, because it's an input element with type checkbox, and the text we want for the task. And at the bottom, we export task so that way other modules in our code can use it, which we'll get into when we look at task list in a second. So yeah, these are task components right here, the rendered little squares. And this is our CSS, which we'll get into towards the end. Okay, so there are basically two kinds of things you want to do with components in React. You either want to draw something to the screen and say, here, give me a square and put some text in it with a checkbox, or you want to do some state management. You want to say, I have an array of tasks. Some of them are completed, some of them aren't. I might need to fetch from a third-party API. For example, if you use the HackerU dashboard during HackerU, there was a little panel with all the announcements from Slack, that there was a Slack controller that made HTTP requests out to the endpoint, and then it came back and it gave them the Slack message components, and the message components knew how to draw them to the screen. So there are function components and there are class components. Function components, like you saw just before with task, there's just a function, they take arguments, and they return components. They're really simple and really nice, and one of the things that's really nice about them is that at runtime, they're basically like free. They don't have any overhead, so you can add as many function components as you want, and it won't make your page really any slower, because they don't have methods attached to them. They don't have to worry about, when do I run some more code to make sure my state's updated, because function components don't have to have state. They just render data. Class components, or we get into the complex stuff, making queries, managing state, global context, all that stuff. They take data as props, but they also have state and life cycle. So you can run some code, for example, every time you get new props. So class components, the best practice is that class components you use to manage data, and function components you use to render views. So our component layout is basically just two components, which is nice and simple. It's one top-level controlling component, task list, which is a class component, and one view component, task, which is a function component, which you saw before. So let's look at task list, which is a little bit more complicated. It is like 75 lines as opposed to 15. So first syntactic difference is we are doing this import right here. Basically, in JavaScript, every module exports something default. So React is the default export from React. But you can also export other named items. So we import the component class, which we extend to make our class component. So class components are any class that extends component. And we import our task from before. So we have some state right here. As we can see, the upcoming state corresponds to the unchecked tasks. The complete state corresponds to the checked task. And the new task text actually corresponds to what's in this box. So we can add a new component by clicking, filling out some text and clicking the button. We can check it off. We can uncheck it like that. So my advice, whenever you're reading a React class component, there's going to be probably a bunch of methods. And we can see here there's just a bunch of stuff happening. The important stuff happens in the render method. And from there, you can read out to see what else is going on. Because the render method is what ends up actually on the page. So we start with our h1, which in a development just means the biggest header you can give me. There's an h2, which is slightly smaller, h3, etc., all the way down to h6, I think. And then we have our div up here, which groups together our input text box and our add task button. So our input text box has some things going on we'll get into. And then at the bottom, we call this.render tasks. I'm going to give a little bit more room to the code, so that way it's not as wrapped. OK. So we have some things happening here. What's this syntax? This syntax, if you remember, is how we just insert arbitrary JavaScript into our JSX. So we call the render tasks method, which returns some components to put into here to render on the screen. Right? So let's go into render tasks first. We call tasks.map here. If you're familiar with functional programming, map will be familiar. But if you're not, map basically means we take an array, and we apply the function to every element in the array. So if we have an array of 1, 2, 3, and 4, and we map a function that squares integers over it, we get back 1, 4, 9, and 16. So this function takes a task object. It's a fat arrow function like we saw before, and returns a task component. Completed is if the list of tasks for rendering are completed tasks. The key we'll get into in a second. On change, we toggle this task to be either from completed to not completed, or from not completed to completed. And for text, we have this text right here. So key is just a thing React does to make sure it can keep track of your components. If you have unique IDs attached to things, you want to keep them with the same key when you render them. Now, any questions right now before we go into the rest of the methods in this class?
Does React use keys internally to optimize rendering?
Yes, React uses keys internally so it can keep track of components. So if it knows that the component with the same key has the same value, it doesn't need to re-render it.
Okay.
So most of the time, you don't have to worry about it. When you're rendering arrays, you might want to put it in there. But you can mostly not think about it. Your compiler will just complain at you. So when we click this check button, some code gets executed. That was the worst example because it's right at the edge. But as you can see, we can check off tasks and they move around. So what's actually happening there is toggle task. Toggle task is a function that takes a task and sees if it can find it in upcoming. Is it an upcoming task? If it is, we're going to remove it from upcoming, and add it to complete. So this is kind of a weird thing we're doing right here, right? Normally in JavaScript, if you wanted to remove something from an array, you would just probably call find it and then use splice. And if you wanted to add something, you would just use push, right? So why are we using set state and concat and filter? Basically, React doesn't like it when you edit objects. You kind of want to just use set state with new clones of objects. That way, if you use set state, it knows what you've changed, so it can go through and re-render specific things. So if you set state and it knows, oh, you only changed this task, right? You only changed example test 3. It just changed example test 3, and that's it. Nothing else on this page has to get re-rendered. So we basically say, filter out any tasks that match the task we're removing, and put this task in the front of complete. If it wasn't in upcoming, it's incomplete, so we do the opposite, right? So the last method is add task. Add task is what happens when we click this button, conveniently named add task. So the first thing we do is we find all the IDs of all the tasks in state. So as you can see, each task has its own unique integer ID. That way we can keep track of it, right? Because we don't want, for example, let's say we have 2 tasks with the same text, not unique and not unique. If we didn't have some ID here, and I checked one of them off, it'd be hard to distinguish which one should get checked off and which one should stay unchecked. So the ID basically helps us keep track of them regardless of if their text matches. We make a new ID, which is bigger than the maximum, so math.max.apply to all IDs. We just find the biggest ID and we add 1. Now we have a new ID that's unique. We make a new task object, which follows this.state.newTaskText. So I said before, new task text maps to this text box. We didn't actually go into how it does that. There's something called a controlled component. So in HTML normally, the way you deal with components and text boxes and things like that, you just find it with a selector. You say document.getElement.id, and the ID is input text box, right? And you just get the value out of it. But here we can't do that because we don't really want to ever use the actual document with React. We kind of just want to keep everything in React. So what we do is we say on change. Every time we change the value in the text box, just update the state in React. And the value in the text box is our state. So if we add a character here, the browser dispatches an event. React realizes something's changed. It changes its own internal understanding of what the value is. And then it keeps the text box consistent. So if you add characters, they show up here. Right? So that's our class component. Before we move on from that, anyone have any questions about that component or class components as a concept? Okay. So looking at styling, because if you just have a plain application with no styles, I can show you how bad that would look with our little to-do app. So our to-do app has very little CSS. You can see I applied very little CSS to this. But it's enough that if I were to remove it, right, let's just remove that line for a second. And rebuild. CSS is sometimes for aesthetic purposes, but sometimes, as you can see here, that was pretty functionally critical. Because now I have no idea, what does this checkbox mean? Does it go to this? Does that go to this? I have no idea. So we have to worry about, even if you're not a designer, you have to worry about styling, and you have to know CSS. If you're going to do any front-end work at all, you need to know at least a little bit of CSS. But you don't have to necessarily just write all the CSS from scratch yourself, right? Because as like I said, you might not be a designer. You might just be a front-end developer. So there's two kind of like CSS ideologies. There's 2 ways you can write CSS for the web using frameworks. There's semantic CSS and atomic CSS. So basically, you can either attach specific values to specific components. So you have, for example, in HTML5, a header component. And you can say in CSS, make the header look like this, and then make all the images in the header look like that, and you can plug it in like that. Or you can use atomic CSS, basically define a bunch of rules, and then apply them to components with classes. So this is Semantic UI, which is a semantic CSS framework, and Bootstrap, which is more of an atomic CSS framework. So either works with React, right? There is semantic UI for React and Bootstrap for React. So both of them work just fine. So you can write class name as a specific class, and that lets you hook into your document and do styling. So I use Tachyons, which is a CSS framework that uses atomic CSS. So if we go back over, we can take a look at task. So task has a pretty long class name list, right? Can everyone read that? OK, so if we could read this left to right, each word is actually a different CSS property, basically, that we're packaging up from tachyons and applying to the component. So we're using Flex. So Flex is basically a CSS tool that lets you linearly lay out data. So if I want my data to be horizontally laid out like this, with a checkbox and then some text next to it, instead of just vertically laid out, I would use Flex. So we say Flex. Flex by default on the web goes left to right. And we say center our items vertically and center them horizontally. So if we make this a ton bigger, we can see that it stays relatively centered. It stays vertically and horizontally centered. So that's what item center and justify center mean. So we have BR3 here. BR is for border radius. So if you look closely, the edges of these boxes are kind of curved, which isn't the default, really. Border radius lets us define that. So if we increased border radius to BR5, then because the radius is bigger, the circle is kind of less rounded. So we have a little bit of less rounding on our corners. If we change to BR1, it's a little more rounded. So basically, each little item here is a logical atom that we can use to style things. And it's almost like a sub-language you can learn to read. So it's consistent. Margin, for example, this is a margin around of 3. If I made this a margin, if I want to make a margin vertical of 3 instead of a margin around, I can just change that A to a V. Padding follows the same scheme. So this is padding vertical 2 and padding horizontal 4. And margin versus padding, those are CSS concepts that allow us to apply spacing, right? So padding basically says, I want to leave this much space inside my box. So I have a horizontal padding. I want to make sure the left edge of the box is this far from the first thing inside it, and the right edge is this far. Padding vertical, for up and down. Margin is how far the box is from its surroundings. So if I have a vertical margin, it should be this far from the next thing that's up or the next thing that's down. So those are what you can use to space out things in CSS. And we have a width of 30%. So if we change that to W90, now it's a width of 90%, and everything is uncomfortably wide. So in my experience, semantic CSS, when you're trying to hook into your document structure, tends to break really easily. Because let's say you add a new div one day, you add a new component somewhere on the page, you might go and break all of your old CSS. You might just end up adding new CSS rules to the end of the document, and it turns into a mess really fast. So I find atomic CSS is way cleaner. I was talking about with the logical scheme of the atoms. So before we get into the review and conclusion, show some things like responsiveness. So one of the nice things about Tachyons and React is they're both responsive frameworks. So what's that mean? Basically, if you notice, if I make this really small, it still kind of works, right? You kind of want to avoid using absolute units in React because, or in CSS in general. If I said this should be 5 pixels wide, and then I blow it up to a giant screen, it'll look terrible. Whereas this kind of scales naturally. So you generally want to avoid absolute values. So before we, so in summary, React allows you to use your PowerPoint wrong, apparently. React allows you to use maintainable, reusable, and efficient re-rendering code. Everything is a component, and components are made of components. You use function components to view data, and class components to control data. And here's some further things if you want to get into the React ecosystem. If you want to set up a React app quickly, you can use create React app, which creates the project structure for you, adds all the dependencies. If you want to install dependencies, you can use npm. Yarn is Facebook's basically clone of npm, which you can use also if you have it. They're basically exactly the same. Redux allows you to do application-wide state management. React Router allows you to have sublinks within your application. And styling, you can use tachyons or React Bootstrap. Does anyone have any questions?
So could you kind of like explain more like thoroughly like what semantic styling is versus atomic styling?
Sure. So let's do some semantic styling real quick right now. All right? Let's say the class name of this is just task. All right? And we can come in here and into our CSS and say tasks are flexbox items, right? So in CSS, this dot means anything with the class name, and this is the class name we use in display flex. So this means that we are vertically centered, etc. So we can apply things like this. So border radius. And sorry, I'm not super used to REPL.it.
Maybe you could show like a more generic description, like maybe on the whiteboard
Yeah.
instead of doing like a concrete.
Yeah, so you can see here, basically the idea is we write CSS that has rules that apply to specific application-specific concepts. So we would say, like, let's say we wanted to make all the, so if we wanted to make the text in our task divs a certain color, right? One way we could do that is to go in here and apply a class name here that's like red, for example, right? Or we could do we could add a rule. CSS has the ability to have complex selectors. So basically, that means that with anything that is a class of .text and has a child paragraph tag, we're going to make the color red. I said text instead of task. OK, that's the problem. So this looks like it works great immediately because, like, oh, we can write complex stuff and it works just fine. So we can say the paragraph tags in texts are this, but the paragraph tags that aren't are different. They, I don't know, they're underlined. But the problem you run into is, what if I were to add a new div here? Because we have some new requirements and we need to add an image tag of some sort. Right? Well, we rapidly start divorcing our CSS from our actual like rendered HTML. Because suddenly, like, okay, what does this apply to? Any paragraph tag is a child of tasks, right? Now we have nesting, and we have to deal with nested selectors. And if you were to read through the code and say, what does that get applied to? You look at this, you say, that's a task. Does it have any paragraph children? No. This component does have a paragraph child, which you could miss. Or if I were to, in task list, apply a class name here, the changes could cascade through the document. So basically, the thing you're trying to avoid is like spooky action at a distance. In React, your HTML is going to be spread out over dozens of components, you don't want to apply CSS to all of them kind of blindly. Any other questions?
So how does Atomic kind of oppose to that?
Okay, so the way Atomic is like opposed to that and make sure you don't run into those kind of issues is that you define, well, generally you pull in someone else's library because defining a bunch of CSS atoms takes a while. So for this example, I pulled in tachyons. I'll pull up their page. Yeah, so I pulled in this library, which just because it's quick and easy to pull in. And then they've defined some names here. So they defined the names flex, item, center, etc. And I don't have to worry about, is something else going to come in and restyle my paragraph tag? Because my paragraph tag also has all the styling applied right here. It's got a horizontal margin of 1, right? And if I want to give it a vertical margin, I could just add a new rule right here, and I know locality-wise it's applied to only this tag. So a lot of best practices of React are avoiding kind of things coming in from other parts of your application and breaking stuff. So if your CSS is all applied within the class, you don't have to worry about basically external breakage.
What other like things have been made like with React? Just overview examples.
Okay. Some big ones are basically any Facebook product you use. So Facebook.com, Messenger.com. Those are React apps, largely because if you are re-rendering the entire timeline, the entire timeline every time someone posts something, you could have problems. You'll get screen flashes. You'll get all sorts of weird issues because if you have 1,000 posts loaded and you re-render that entire thing every 10 seconds, you'll get huge breakages. So it uses React, and it makes sure that it only updates the parts of the page it needs to. And by extension, the Facebook app and the Messenger app on your phone use React Native, which is React but for your phone. Yeah?
So going back to what you're talking about with the types of styling,
Yeah.
something called like inline styles with CSS,
Yeah.
with React, right?
Mhm.
Would that fall under?
Inline styling is, it's not really using a CSS framework, which is why I didn't get too much into it, but yeah, that's definitely a very common thing to do, which is basically, there's two options there. You can just write CSS you can write like style equals, and then put some styling in there. Or you can use something called JSS, which is JavaScript style sheets, where you define objects in JavaScript that are like CSS. So where in CSS I would write like a paragraph tag like that, in JSS I would write maybe my styles equals an object or paragraph color red, right? And then I can just put in, using JSS library you have to pull in, the styles for this object come from this component come from this object. And it lets you do a lot of flexibility, like programmatic styles, but it also does require kind of like a heavy dependency, in my opinion. But if you are changing large elements of your design often, or you want a lot of granular control over your design, that's really good. Because a downside of the way I have Atomic CSS set up here is if I want a margin that's between margin 2 and margin 3 that the framework is defined, I'm kind of out of luck, right? I'd have to go write my own atom for that. Whereas if you are maintaining your own styles with JSS, you could just edit the value you put in. You also had a question, right?
Yeah.
Sure.
So like you explain a lot of stuff, but like one question I had was like,
Sure.
What do event listeners do?
Okay, yeah. Sorry, I made some assumptions that about web stuff, because that's just like unknown nodes. Basically, the browser works in a model where you can ask it, whenever this action happens, call this method. So if you were writing JavaScript directly, you would write something like, given some element, so we could get element by ID, task dot on click equals And then we can do something there, right? So we can say on click, do this. And then when the button's clicked, it'll call our JavaScript code and run it. With React, we can just say in the component itself, we say on change equals some function right here. And then React attaches it for us. Basically, whenever the user interacts with the page, the browser can fire off JavaScript code. So here, for example, the JavaScript code we fire off is updating our internal understanding of what's in this text box with the actual value. So whatever, we take the event, we look at the target of the event. So in web development, event targets or whatever object signaled an event. So in this case, this text box is signaling an event, hey, my text has been changed to have a bunch of T's in it. So event.targets in text box, and value is what's, for a text box, what's written in there. So this allows us to, whenever someone edits a text for there, run some code. Here we have an onClick. Let's expand this again, because of the code wrap, it makes it hard to read. Here, the onClick basically means that if I click this button, it'll run this code, and it'll run this .add task, which is up here. So whenever this button is clicked, this method runs. The browser takes care of that kind of behind the scenes, so you don't have to worry too much about how the events actually get called. There's a variety of events you can hook into. You can say on change, on click, on hover. You can run code when the app starts, when an image loads, for example. So all sorts of things. Yeah.
What other online resources would you recommend for anyone wanting to learn more about React?
I would recommend, actually, one place, there's some resources for React. If you go to the GitHub repo for the HackerU frontend, which is github.com/hackeru/frontend, we've kind of compiled links to some things to learn web development, to onboard new members. So you can look at W3 schools and MDN to learn about things like HTML5, JS, and CSS. And you can look at this. So reactjs.org, for example, has their own React tutorial, which assumes somewhat development knowledge. If you want to learn something like Redux, which is what we use to manage our state, you can look here. So there's a bunch of resources in this README. I can't claim credit for this. My predecessor wrote most of this. But this is really helpful for me and some of the other members in the team. So it's github.com/hackeru/frontend. Any other questions? All right, I think that's it then. Thanks, everybody. If anybody wants to ask me anything about React or anything development related, feel free. Thanks for coming out.